Hey everyone. This is Miss Cram, and I think most of you know that I am making these Desmos activities for you. And so I've gotten a few emails and a few of you that were just concerned with some of the slides, whether it was, did I do this right? Or I didn't understand how to do whatever. So, what I'm doing in this video, or at least what my purpose of doing this video is to go through the Desmos and do most, if not all, of the slides. So that might take a long time. And for that reason, I think that really, if you had a problem like with slide 3, then just kind of click through until you get to slide 3 and look at the work that I did there, right? So it's not a video that you have to watch all of the way through. Okay, so let's get started. So let's look at slide 2. That was a noticing and wondering. So I'm not going to spend too much time on that. Let me see if I can move myself around. Um, some people, some of the most common noticings were that these are different graphs, right? They have some different numbers in them. Another noticing was that all of them have kind of this shape. All right. And kind of making the connection between this shape and having three factors. And actually, let me point out a couple things here. So, in this parentheses, this is considered to be a factor, right? And in fact, this is called factored form. Okay. Anytime you have these parentheses. The last time you probably saw factored form was maybe when I taught you, or Miss Amarante taught you, where it was quadratics we were talking about. But, anyways, whenever you have like those parentheses, this quantity times that quantity, that's factored form, as opposed to standard form, which is like x squared plus 2x plus 1, right? Where you don't have any parentheses in there. Um, Okay, and then the last thing, oh, I'm at my mom's in Connecticut and she has a dog. So if you hear the dog barking, don't worry about it. All right. So the last thing to kind of notice, and I know that these numbers are really small, is that this is at -4. And if you notice, this is a +4, right? This one is at -1. And if you notice, this is a +1, right? And this one is at a +2 on the x-axis. And here I have a -2. All right. So we're going to go into that relationship a little bit more, that whatever these x values are on the x-axis, we actually call those zeros. So these numbers right here, where I have these three dots, 1, 2, 3, those values we call zeros. Okay. And the reason that we call them zeros is, if I were to actually write this point out, this is the x value is 2, the y value is always 0. All right. So there's the 0 right there. And that's true for any of these 3 points, right? The y value will be 0. The other way you can think about it is, if I put in x equals 2, if I replace that here, if I say, okay, this x is 2, 2 minus 2 is 0. One of the factors will simplify to 0. Okay. So actually, that's all I'm going to say about this slide. If you noticed some other things or had any questions, um, then, then that's great. All right, so let's clear that and we're gonna just move on. Okay, so this was really a combining like terms. So this parentheses tells you that you're grouping, right? So if you think of PEMDAS or something like that, the P always goes first. So we're like looking at uh, the parentheses plus another parentheses. All right, and that part is actually pretty important, this plus sign. All right, so we are adding anything that we have in this grouping, this parentheses, to anything in this parentheses. And how we're going to do that is something called combining like terms. So whenever you are adding, whenever you're finding the sum of something, then you need to find terms that have the same variable. Like here I have x, but it's not a like term with this one, even though this also has an x. It's because this one is an x squared. So not only does the variable need to match, but the exponent also needs to match. So 5x to the fourth could be added or subtracted to another x to the fourth, right? All right, so I'm just gonna like pair those like terms up and do what the operation in the middle is. So I'm gonna say 4x squared plus negative 6x. Sorry, it's late here. It's not that late, but it's late for me. 5x to the fourth, I think I said 5x squared. 5x to the fourth plus negative 6x to the fourth. All right, so that would give you negative 1x to the fourth, right? So nothing about this exponent or the variable has changed. The only thing I really did is once I figured out that they're like terms, I said, hey, 5, the coefficient, plus negative 6, and that's what gave me negative 1. Okay. Now I'm going to do the same with the others. So I've got a minus or a negative 4x squared plus negative 2x squared, right? So again, the x squared stays exactly the same. That's why we have to get them the same. That's why we have to match them up and combine like terms. So x squared doesn't change, but now I've got the coefficients negative 4 plus negative 2, which gives me negative 6. So negative 6x squared. All right, and then the last ones, the negative 7 and negative 3, they don't have any variables. Those are like terms. So just negative 7 plus, right? We always need to remember that operation in the middle. Negative 7 plus negative 3, which is negative 10. Some of you got this and it said like it's close or something like that. I think that it was kind of picky about it didn't want any spaces in between. So if that happened to you where it said, hey, you're close, but not quite, please go back and just try to take out any spaces and it should clear it right up. Okay, so now let's go to all right, we don't have to go through that because that video kind of just did what I did. It showed you how to do the problem on slide 3. Okay, so this one, I'm just going to point out the connection. So when you plugged in x equals negative 5, that means for any x, you're going to replace it with a 5, right? So this x, I'm going to replace with a 5, right? All the x's get replaced with 5s. Okay. And now I'm just going to simplify. All right. So I have my 4 and 5 minus 2 is 3. Okay. And then 5 minus 3 is 2. Cool. All right. Now I have my plus and I'm going to put 7. 5 minus 2 is 3. Okay. 5 minus 5 is 0. And now I'm following along. So minus 6. All right, now 5 minus 3 is 2. And here in this last parentheses, 5 minus 5 is 0. Okay. I did see some people that were trying to distribute. And when you're evaluating, when they actually give you the variable, the first thing you should do is simplify anything in the parentheses. Okay. And then it's all the multiplication gets done next. The addition or subtraction, those would come last. All right. So here, I'm just going to do this real quick. 4 times 3 is 12. Times 2 is 24. Okay. Um, 7 times 3 is 21, times 0, oh, that gives me 0, okay? Negative 6 times 2 is negative 12, and negative 12 times 0 is also 0. Okay, so that's interesting. When x is replaced here and here, not only does it make this simplify to 0, but it also makes anything that that factor multiplies with, it also makes that entire thing 0, right? Like, by entire thing, I mean 6 times 2 times 0, all of that turns into 0, right? So the simplification here, 24 plus 0 minus 0 is still 24. Okay, so this would be your answer. But the most important thing for us to note today is that when I have an x value that is replacing, or sorry, a value that's replacing x, and it turns one factor into 0, it also turns the entire, um, what should we call this? Like the entire product, entire thing that that factor is being multiplied by. It turns this whole thing, 7 times 3 times 0, into 0. Okay. So just kind of keep that in mind because that's a big connection for this lesson. All right. Let's clear that and go on to slide 6. Okay. Great. A lot of you, I was looking through the slides, and a lot of you were really close. So remember what we did on the last slide where that 5, when we replaced it in some of the parentheses, and I'm calling those parentheses factors, right? In some of those, it turned it to 0. So if I'm saying which polynomial function has zeros, I can use this word, right, when any of the x values turn one of the factors, at least one of the factors, into 0. So like when x is -2, all right, well, if I'm plugging in -2 here, -2 times -2 is -4, right? That's not 0. And I don't really see in either of the other two factors where replacing -2 would give me a 0. Okay. Same thing here, right? If I replace this, again, -2 minus 2, -4. And if I replace either of these x's with -2, it doesn't seem likely that it will give me a 0. All right. Whereas when I go here in this third one, all right, -2 plus 2, that does give me a 0. That is a really good sign. So I would consider -2 to be a 0 of this um, third function. Okay. Now let me try 3/4. So if I multiply 3, and this might get a little messy, but if I multiply 3 by 3/4, okay, it's hard to write with this. Okay. All right. So 3 times 3/4. All right. So that would be 9/4 minus 5. Let me just do that over here real quick. So I'm just doing 3 times 3 is 9/4 minus 4. Okay. So 9 divided by 4, well, it's not, I could do this in my head. I could use a calculator, but 9 divided by 4 is not going to give me 4, right? And I would need a 4 to be here so that when I subtract this 4, it gives me 0, right? So this is not going to give me a 0, right? And if I replace this x with 3/4, 3/4 plus 2, not 0, 3/4 plus 5, not 0, okay? So this 3/4 does not work for the third function. All right, so let me try the last function. So here I've got -2, -2 plus 2. That does give me 0. Yes, -2 is a 0 of this function. All right, now what about 3/4? Oh, I don't know why I'm checking it. Okay, so I need to test it first. So instead of x here, right, I'm just kind of crossing that out. I'm going to multiply this by 3/4. Okay, so even if that doesn't look like 3/4, please take my word for it. So again, let me use my side over here. So 4 times 3 is 12. Okay, 12 over 4, right? I'm just multiplying. 4 times 3 is 12, and then divided by 4, okay? And then I think that this was a minus. Yeah, that looks like a minus 3. Okay, so now 12 divided by 4 is 3. Oh, and so here, 3 minus 3, that does equal 0. So if I replace 3/4 for x in this middle factor, it will simplify to a 0. I'm glad that I put the check. I put it a little too early, but that does work. 3/4 is a factor for this last one. Okay. And now let me check 5. 5, if I plugged in this first one, 5 plus 2 is 7. No, but here I can see 5. If I replace this x with 5, 5 minus 5 is 0. So remember, it doesn't have to be that -2 turns all of the parentheses or all of the factors into zeros. It just has to turn one of the factors into a 0. Okay. All right. So the answer should have been this last one because each of these numbers makes one of the factors equal to 0. Okay. All right. So graphing, this should be pretty easy. Whenever you're asked to graph anything, you can really just put f of x equals, and then, so I'm just literally typing this out. So if anyone was confused, how do I do that? You literally are just typing out um, whatever your function you're given. And also, just to bring it up here, if you're given an exponent, you press the shift button followed by 6. So shift 6. And if you look at 6, it has like a little caret, a little arrow up. That's what brings you there. Okay. And this problem, we actually don't need that. Let me see if I can delete it. Okay, so we just need this -3. Okay, and +3. Okay, so if you look at this, I mean, should probably zoom out a little just to see the shape of the graph. But if you look at this, oh, let me put that parentheses, you'll see that um, I have 3 parentheses, and let's go for the easy ones first. So what number -4 gives me 0? Okay, if you said +4, you'd be right. 4 minus 4 is 0. And if I look right here, I see that x-intercept. And actually, another name for zeros are x-intercepts. Okay, so if you see right here, we've got 4, 0. So this one, what number when you add 3 to it will give you 0? If you said -3, you would be correct. And I would look right here, -3. Okay, this one's a little bit more difficult, so I'm actually gonna just see. So I have 2x minus 3 equals, and remember, I want all of these to equal 0, right? So I could have done that for these other two factors. So let me just do this real quick. So +3 on both sides. 3. All right, I'm going to divide by 2. Okay, so it looks like x would be a +3/2. And if I did that division, I would get 1.5, right? So you can do the decimal or the fraction version. And so when I go back over here, let's see. See, there you go, a +1.5. All right. So if I did 2 times 1.5, right? 1.5 of 2 is 3, right? -3 gives me 0. Okay. So really be making these connections between where the graph crosses your x-axis. That x value, when I plug it in, it will turn one of your factors into 0. All right, so let's see what the next slide has for us. Okay, so we actually just did this. What were the 3 x values? And let me see if I can remember them. My memory is really bad, but let's try this. So I believe it was x equals a +3/2 or 1.5. And then this one, I'm pointing to it. Okay, this one, 4 minus 4. So it was x equals a +4 because +4 minus 4 is 0. And then here we have -3, right? Where x was -3, -3 plus 3 gives me 0. Okay, so those would be your three x values um, that again are called x-intercepts. So zeros and intercepts are exactly the same thing. Zeros is really another name for x-intercepts. All right, I'm just going to abbreviate it because it's hard to write on the computer like this. Um, okay, so yeah, it's always the x value. Okay. All right, lesson videos. Yeah, these were good, especially if you forget even what factoring is. This is kind of like a ninth grade, just memory check, right? It's been a few years. So I would really highly recommend that. But then this is more like what we were doing today. So, kind of for some extra support, please watch those. They're on YouTube. Okay, so these I'm going to match and just kind of give a brief description. So if you match them, but you were not sure if you got them correct, we're going to match them and make sure that they're correct. Okay. All right, so let's kind of go one by one. So here I see 4, 2, -1, and -3. All right, so these would be my zeros. So I'm actually going to organize this. I'm going to put all of my factored form equations over on this side. So here I've got all these equations. This is an equation, and I'm going to put all of my um, zeros, right? My x values, my x-intercepts on the right side. Okay, so I'm moving these to the right side and I'm moving those to the left. Okay, all right, so I'm thinking to myself here, right? X squared. Okay, so I need this whole thing to be a 4 because 4 minus 4 would give me a 0 here. So what number squared would give me 4? Okay, so I'm thinking 2. Okay, so 2 squared is 4, but also remember -2. -2 times -2 is also a positive 4, right? So I'm looking where x is either a 2 or a -2, right? And then in this one, what would make this factor a 0? Okay, so hopefully you said -9. So -9 plus 9, that's 0 also. So I'm looking for 2, -2, and -9, right? So here, these two are a match. And in order for it to be counted as a match, like in this program, you need to make sure that they click, right? Okay, so here we go. So those are a match. I'm actually going to click them so that it minimizes, but just know that those two are a match. Okay, and let's put those way over here. All right, so now let's see. All right, so let's look at this one. So 2x plus 8. Well, I know that this would have to be a -8, right? Because -8 plus 8 is 0. So what 2 times what number would be -8? Right. Oh, okay, I think I got it. So -4, right? So 2 times -4 would give me -8 plus 8. That would make this 0. So I'm looking for -4, trying to remember that. Now this one looks tricky, All right, so I'm just gonna hold off. Here, a number minus 10. So I think that this is 10. 10 minus 10 is 0. So I'm looking for -4, positive 10, and something here. Can you tell whether it would be a positive or a negative number that we're looking for? Okay, right? So think about it. Remember, here we're looking for a negative number, right? -4. Here we're looking for a positive number, and I've got subtraction. So here I'm actually looking for a positive number. All right. So -4, positive 10. This looks like a match, right? And I could plug in 3 sevenths. 7 times 3 is 21, divided by 7 is 3, and 3 minus 3 is 0. Okay, so you can either do that in your calculator or mental math. So I used a little mental math there. All right, so those are good. And now let's see. Well, this is interesting. It has x on the outside, right? So x is just by itself. So the number needed for this one would be 0. If this x was 0, right, I'm not adding or subtracting anything to make it 0. It's just 0. So like here when I'm looking, so it's probably this one, right? Because if x were 0, it would turn this to 0, which would make all of them 0, right? 0 times anything is 0. All right. So now 3 minus 3. So I'm looking for a positive 3. Up. I think that this is it. 1 minus 1. So I'm looking for a positive 1 for x. Yes. And then negative 0.75 plus 7 or plus 0.75. That also gives me 0. So these two would match. And just a note, feel free to pause this, if I'm going a little too fast or, figure out how to pace it so that it works for you. Okay, so now here, ooh, look at that one. That one's a little different. I'm going to save it till last. They threw in a little standard form here, right? All right, so here we go. Um, so I'm looking for x plus 4, so negative 4, right? So I'm looking for a negative 4, a negative 2, a positive 1, and this is x, they're on two lines, but this is x minus 3. So that would be a positive 3. 3 minus 3 would be 0. So I'm looking for this one. Okay. All right. This negative 2 out front, there's no x with it. There's no way I can change this negative 2 to a 0. So there wouldn't be any 0 here, right? It's just a negative 2. It only works if I can substitute in an x value that turns the factor to 0. Okay, so this negative 2, it's just negative 2. That's the factor. It's not going to change. Here, okay, 4. So positive 4 minus 4. So I'm looking for a positive 4, a positive 2, a negative 1, and a negative 3 because I have x plus 3. So I need a negative 3 plus 3. So positive 4, let me just make sure. Okay, 4 minus 4 is 0, 2 minus 2 is 0, negative 1 plus 1 is 0, and negative 3 plus 3 is 0. Yeah, good. All right, so here we go. All right, x plus 4 squared. All right, so this is interesting. The square being on the outside of it, unless the exponent is actually with the x, I'm not going to need two different x values, right? I just want to know inside the parentheses, x plus 4, what would x have to be? Hopefully you're catching on, negative 4, right? So negative 4 plus 4 is 0. 0 squared is still 0, okay? And then on this one, negative 2. Negative 2 plus 2 is 0. And 0 squared, again, is 0. Okay, so let's see, take a look at that. All right, and then here we've got factored form. So again, this is a really great just comparison. This is standard form, and then here's factored form. All right, so here I've got a positive 4, so negative 4 plus 4, negative 2, I think I see it right here, right? Uh, and then 1, 1 minus 1, 0. Okay, that just leaves one more. So you could do process of elimination, but I also want to just double check. So here, x is negative 4, and I'm still going to do some mental math, but if I'm plugging in x, it's got to be in both places. So I'm not putting negative 4 here and 1 here. If I choose negative 4 as a replacement for x, I've got to use negative 4 here and negative 4 here. Okay, so real quick, negative 4 squared is a positive 16. Right? Negative 4 times negative 4 is a positive 16. Now, 3 times negative 4 is negative 12 minus 4, because that's just there, equals 0. Okay, so 16 minus 12 is 4, and 4 minus 4 is 0. All right, so that one, excellent. Now, let me try the 1. All right, 1 squared is 1. 3 times 1 is 3. So 1 plus 3 is 4. Okay, cool. And then I've got this minus 4. All right, so that also works because 1 plus 3 is 4, 4 minus 4 is 0. Okay, so these both work in the fact that when I plug them in for x and I simplify, I will get it to equal 0. Factoring is just a little bit easier. In factored form, you can easily see, oh, okay, 4 minus 4 is 0, 1 minus 1, something like that. Okay, all right, so these two are definitely fully confirmed a match. Okay. So yeah, so if you ever have any questions about like, hey, is this card sort correct? Feel free to shoot me an email. Okay. Oh, so these were really fun. I'll just do them quickly because they're actually kind of fun to do. So drag point A, and this might be if you're just not familiar with Desmos, to move the parabola. So you actually are going to literally take this and you're going to move it until you get lined up, right? So in this case, your zeros are 2, positive 2, and a positive 6. All right. So if I were working backwards, and they're probably going to do this on the future slide, so I probably don't have to do this. But if I were writing this in factored form, right, if x was 2, 2 minus 2 would be 0, right? And if x was 6, right, x was 6, 6 minus 6 is 0. So if I'm given this parabola, and asked to write it in factored form, I can just write the factored form knowing that these x values would have to make one or at least one of the factors 0. Okay, so let's see. They probably are going to ask us to do that in the very next slide. Yeah, okay, so here is that. They put it into an equation, right? All right, so what relationship do you see between the function? I'm going to kind of leave that to you. We've talked a lot about like kind of what is the relationship between this x value and how it's shown in the equation or represented. Okay, so let's go to 13. Okay, use what you noticed on the last screen to write a function for a parabola. And remember, function is just a fancy word for equation. All right. And it's usually an equation that instead of being started with a y, it started with an f of x. All right. Okay. So whose zeros are the 2 open blue points? All right. So here I can't drag anything. I've actually got to write it. So maybe I think, all right, so maybe x minus 4 and x plus 7. Okay, let's see. Okay. So I got one of them correct, right? So this x minus 4, right? If I replace x with 4, a positive 4, 4 minus 4, that's 0. So what happened with the other one? Let me see. If I replace this 7 here, 7 plus 7, oh, that's 14. Remember, I want it to be 0. So I need to actually change this to minus 7. Okay, and there we go, right? So once I made that little change, these match. Okay, remember again, 4, if x is 4, 4 minus 4 is 0. If x is 7, 7 minus 7 is 0. Okay. All right, so this one, it's a similar thing. So if x is 3, right, I'm writing x, but it's not 3. If x is negative 3, then I need to add 3 to it in order to get 0. And if x is a positive 2, right, so this x is a positive 2, I need to subtract 2 to get 0. Oh, okay, so write a cubic function. So we haven't really got into what cubic functions are. And so I can kind of play around with this, but cubic functions are functions where the highest exponent is an x to the third. All right, so just like quadratics, the highest exponent is x to the second, x squared. Cubic is the highest exponent is x to the third. So if you were to actually, like, let's just, kind of pretend like x plus, I don't care, a, right? And x plus b, I'm just choosing random letters, right? X plus c, okay? If you were to rewrite this in standard form, right? You were to do all of your x times b, right? Doing multiplying your binomials, multiplying your polynomials. If you were to do all that out, you would get a function that starts with x to the third, right? Because really, x times x is x to the third, right? That may have been way too much, but you're welcome, right? All right, so let's get back to this actual problem. Um, Even though it's not a quadratic, I'm still looking at the exact same points. And they are nice enough to tell me those points, right? Again, quadratic, I've got 3 roots instead of 2, instead of 1. Um, so pause, take a minute, and try to write this equation yourself. All right, so I'm just going to go from left to right. It doesn't matter what order. Multiplication, that commutative property, it doesn't matter what order you write these factors in. So I see a -2 here. So if x is -2, I've got to add 2 to that. Here, I see x is a +2, right? So I would have to subtract 2 to get that to be 0. And here, x is a +6. So if this x is +6, I need to subtract 6 from that. I think I'm going to let you play around with the next few, right? Um, to figure out how many zeros this might have, right? So think about that. Again, it's like in this one, right? There were 3 zeros. 1, 2, 3. All right. So I don't want to do every single slide. I want you to kind of, maybe if some sparks went off, have a chance to do that. This is a summary. So this could be any number, right? So remember, if this was my factor, then x would have to be positive a, because a minus a would give me 0. Okay, so don't get thrown off by the fact that there are letters here instead of numbers. It's the same exact concept. What would you have to turn x into to make that factor equal 0? Okay, and then find the error. The error here was that +5 minus 5. So see how here the x-intercept is at -5? It really should have been a +5. And that's the same, I think, for all of them. +2, and they put it -2, so that was a mistake. It should have been a +2. And the same for this. Here, it's on the positive side. It should have been flipped. So the whole thing should have been like, flipped around a little. Okay, so that is it. Email me again if you have any questions. You should be able to reach me if you remember my email, or on Google Classroom. All right. See you later.